Okay, Year 10. So what we have now is something called the mole tray. And the mole tray is not a collection of cute, furry animals, which would be very, very cute, but it is in fact something far more sinister, a load of chemicals. But the important thing about all the things I'm about to show you is each one of these contains 1 mole of particles. Each thing I'm about to show you contains the same number of building blocks. It's just that the building blocks themselves have different masses. So let's start with 2 non-metal elements down here. See if you can work out what these 2 elements might be from the colour or from the looks of them. You should recognise them both from previous years. Hopefully you recognise the yellow of sulphur on the left, and on the right you recognise graphite, which is a form of carbon. So bearing in mind there is 1 mole in each of those jars, how heavy is the contents of each jar? Which one's heavier? Is it the yellow sulphur or is it the black carbon? Now for those of you who can read backwards, I'm sure you know the answer, but ta-da! Although these contain the same number of atoms, because a sulphur atom is about 3 times as heavy as a carbon atom, 1 mole of sulphur is about 3 times as heavy as 1 mole of carbon. Now let's look at some metallic elements. We've got 4 metals here. Again, can you work out from just looking at them what each of these metals is? Well, I'm hoping you recognise on the right-hand side magnesium ribbon. You've got some nails on the second to right, which of course would suggest iron. You've got the lovely shiny red of copper there. And then this material here, some of you may recognise it, it's lead. Quite toxic, we certainly wouldn't let you play with that. Again, how heavy are the contents of each jar? Mr. Reeves, if you lift up the magnesium quickly, and then the lead, how much harder do you think it was to lift up the lead? Well, if Mr. Reeves now reveals the answer, the jar of magnesium contained 24 grams of material. The jar of lead, 207 grams of material. Although they have the same number of atoms, a lead atom is about 9 or 10 times as heavy as a magnesium atom. And therefore, a mole of lead is 9 or 10 times as heavy as a mole of magnesium. And in the middle, iron clocks in at 56 grams, copper clocks in at 63.5 grams. So those are the elements. Now let's look at some compounds. And we'll start with these 3 white solids over here. And again, those of you who can read backwards, some clue is being given, but you can see that each of them has very different levels. One of those is sodium chloride, one of them is sodium hydrogen carbonate, and the other one is?
Sodium carbonate.
Sodium carbonate. So sodium chloride, NaCl, sodium hydrogen carbonate, NaHCO3, and sodium carbonate, Na2CO3. Work out how heavy 1 mole of each of those would be and see if you can work out which chemical is in which jar. On my left, Mr. Reeves' right, the heaviest one we have, sodium carbonate, 106 grams per mole. In the middle we have sodium hydrogen carbonate, 84 grams per mole. On the right we have sodium chloride, 58.5 grams per mole. Again, I stress, these contain the same number of particles. They're all 1 mole of particles. It's just that the sodium carbonate is much heavier than the sodium chloride. It's about twice as heavy, so it takes up about twice as much space. And finally, and penultimately actually, we've got 2 liquids here. One of these is water, H2O. One of these is glycerol, which is which? Looking at the volumes of liquid, which one of these is water? Which one of these is glycerol? Well, Mr. Reeves will at last reveal. Water, 18 grams. Glycerol, 92 grams. A particle of glycerol is much heavier, about 4 or 5 times as heavy as a particle of water, and therefore it takes up a lot more space. Now obviously there are other factors involved, how closely the particles pack, etc., but the general trend continues. There's one thing we haven't looked at so far, and that is the size of a mole of gas. So if we start with, let's say, a mole of iron and a mole of glycerol, you can see there a mole of solid atoms, a mole of liquid atoms. How big do you reckon a mole of gas would be? Okay, Mr. Reeves, if you stick it over next to it. We're going to need a wider angle. So zooming out, you can see here a mole of gas takes up a much larger space, much larger volume than a mole of solid or liquid. Although it has exactly the same number of particles, those particles are very spread out, and so it takes a lot more space. Thank you very much, Mr. Reeves.
That's my pleasure, Dr. Nixon.